We have lift stabilization confirmed. Proceed to rotate 0.05 degrees west.
The structural integrity on the lower glacis is compromised. Confirmed. We'll need to prioritize the turret separation first.
Lift slowly now. Watch the alignment on the east link.
Clear on this side, keep it steady.
Rotation is minimal. We have 6 inches of clearance now.
Maintaining perfect balance on the main hoist.
Keep monitoring the hydraulics pressure.
The vision system flagged this one as reactive steel. Verified. Rerouting to the separation zone.
Watch the clearance on that actuator, bring it down slowly.
Gear assembly tagged and ready for the AGV.
Rack 42 is clear, send it over. The spectrometer confirms the high-strength grade on this sample.
Excellent. Ensure the automated sorting matches the database precisely.
Clear the area. The charge is commencing.
Confirmed. All personnel clear.
We've got a spike in carbon at the east lance. Adjusting flow rate now, targeting 200 cubic meters per minute.
Automated charging systems introduce carefully measured alloying elements into the molten steel. Chromium, nickel, molybdenum.
Check the surface quality on billet 12. I see a hairline fracture. Confirmed. Logging the imperfection now.
The cooled billets arrive beneath powerful LED inspection lighting, where robotic laser scanners sweep across every surface.
Heavy-duty automated bandsaws begin dividing the long steel billets into carefully calculated production lengths. Hydraulic clamps lock each billet firmly. The residual stress levels are dropping rapidly. Good. The grain structure is normalizing right on schedule.
The hardened component enters a tempering furnace where carefully reduced temperatures restore toughness without...
The drilled cylinder transfers automatically to a precision honing station, where expandable abrasive stones begin polishing the internal bore. The data confirms the surface is within specifications. Excellent work.
It looks perfect. We can move it to the next stage.
The cylinder blank enters a multi-axis machining center, where automatic tool changers rapidly install carbide end mills and chamfer cutters. The cylinder blank enters a multi-axis machining center, where automatic tool changers rapidly install carbide end mills and chamfer cutters. The completed machining stage concludes inside a fully enclosed robotic finishing cell, where rotating brushes, precision...
Surface roughness is well within tolerance. Confirmed. Ready for sealing.
The alignment is holding perfectly at 5,000 psi.
Force compression remains steady. Looks good.
Look at the pressure curve, perfectly stable.
And the vibration is negligible. The recycled steel holds.
The graph stabilized perfectly.
Confirmed. The recycled steel passed the extreme load test.
The pressure curves are holding steady, well within the durability model. Friction levels look excellent at this speed.
The bearing surfaces are maintaining balanced temperatures.
Excellent. The component is approved for heavy-duty operation. Digital instruments compare theoretical output with measured mechanical force. Every extension and retracture is analyzed.
With mechanical testing complete, the cylinder enters a pristine inspection booth illuminated by high-intensity daylight-balanced safe. The careful packaging process emphasizes that precision manufacturing continues beyond production. Autonomous guided vehicles transport the packaged hydraulic cylinders through wide warehouse aisles. Robotic storage cranes position.
Confirmed. Shipment 34B is cleared for immediate transport. Reroute automated crane 12 to staging area Delta.
The 3B shipment needs priority loading onto transport Gamma. Acknowledged. Adjusting the queue now. Optimization sequence initiated for lane 4.
Acknowledged. Gantry alignment is holding at .02.
Installation secure. Proceed with activation sequence.
Hydraulics engaging smoothly. System nominal.
Tiemens. Massive excavator arms lift multi-ton steel beams, while hydraulic presses compress thick metal plates with effortless.
Through extraordinary engineering, forgotten military hardware is converted into valuable industrial technology. Every vehicle holds the potential for remarkable transformation.
Inside an advanced engineering validation laboratory, multiple hydraulic cylinders manufactured from recycled tank steel.
The pressure retention is completely stable, even with the extreme vibration. The recycled steel is holding up perfectly across all environments.
Every stage, from alloy identification and forging to machining, assembly, and testing, is verified against engineering specifications.
The lift cycle demonstrates the precise control, and as the telemetry shows, we are exceeding the performance metrics of the previous generation.
The continuous exchange illustrates a never-ending cycle of renewal, where every incoming vehicle represents the The transformation is complete, but the factory's mission continues, turning yesterday's battlefield giants into tomorrow's precision engineering solution.
Look at the difference in the grain structure. The refinement is remarkable.
And the fatigue predictions are significantly better than the archived samples.
Look at the stress distribution on the seals here. It matches the physical test results perfectly. The digital twin is validated.
The recovery rates are up by 5% this cycle.
That aligns perfectly with the precision metrics we see here.
Control to maintenance team, we have an AI anomaly in sector G7. Prioritize investigation.
Let's win this. The documentary explores how byproducts generated during recycling are carefully recovered rather than discarded.
What began as worn battlefield machinery has become a symbol of engineering innovation.
All systems green, throughput steady at 90%.
Acknowledged. I'll monitor the automated feeds.
The coordinated expertise of our metallurgists ensures every decision is backed by science. The tensile strength on the x-axis seems
Polished chrome reflects the cycle's restart. As the finished products ship out, the arrival of these retired tanks quietly bridges us to the final chapter.
Across the globe, these cylinders, forged from recycled steel, are integrated into the heavy machinery essential for modern infrastructure.
Hydraulic cylinders manufactured from recycled tank steel operate continuously inside enormous excavators, forging presses, container cranes, and mining machinery.
Look at that recovery rate, 99.8% efficiency.
Truly remarkable. This steel is ready for the next generation.
It's huge. The manufacturing process gives the steel an entirely new purpose, demonstrating how advanced engineering can preserve valuable resources. Recycling is not a beginning or an ending, but a continuous industrial cycle powered by engineering precision and disciplined manufacturing.
The pressure on the main cylinder is holding steady at 5,000 psi.
Good. The stress tests look optimal.
Advanced engineering can completely redefine them through the future of valuable material through knowledge, precision, and disciplined manufacturing, rather than allowing them.
Time-lapse photography compresses several days of factory activity into a single cinematic sequence. Dawn becomes night as production never pauses.
The transformation has come full circle. What once served on the battlefield now powers the industries that